Hello everyone, welcome to last problem solving sessions for linear algebra 1. First question is find the inverse of the matrix 1, 2, 3, 4, 2, 3, 4, 3, 4 and 0, 0, 0, 4 by using Gauss-Jordan method. In the Gauss-Jordan methods, we are trying to solve this augmented matrix. Let's say this is A. In the Gauss-Jordan method, we are writing A to the left side, and in the right side of this augmented matrix, we are writing the identity of n. Since we are 4 by 4, this is 4 by 4, we will use identity matrix of 4 by 4, and we will do some elementary row operation, and we will reach identity 4 by 4 in the left side, and we will reach some matrix in the right side, and this matrix will be the A inverse. This was the Gauss-Jordan methods. Let's try to use this Gauss-Jordan methods. In our case, we have 1, 2, 3, 4, 0, 2, 3, 4 and 0, 0, 3, 4 and 0, 0, 0, 4. This is our matrix. And in the right side we have the 4 by 4 and identity 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Now we need to reach identity here. So here, first thing, okay, there is 1 here, and below this 1 we have zeros, right? So let's try to find 1 here and cancel the other things. There is nothing below this 1, right? But there is 2 above this 1. So we can cancel this 2 by adding minus row 2 to row 1. And this will be the new row 1. So we will get 1, 0, 0, 0, 1, minus 1, 0, 0. Then I will have 2, 0, 2, 3, 4, 0, 1, 0, 0, 0, 0, 3, 4, 0, 0, 1, 0, 0, 0, 0, 4. Also, let me subtract in here. Let me subtract row 4 from row 3, and let me write this one to row 3. Then I will get 0 here, and I will get 0, 0, 1 minus 1 here, and I have here 0, 0, 0, 1. Now, okay, also like in this row I should have only 2 again, right? There is 3 on this row and there is 4 on this row, but there is 2 things here. So let me add minus row 2, 3 to row 2, and yeah, let me add minus row 4, row 2 to row 3, and let me write row 2 here. Then I will have 1, 0, 0, 0, 1 minus 1, 0, 0, 0, 2, 0, 4, 0, 1, minus 1, 1, 0, 0, 3, 0, 0, 0, 1, minus 1, 0, 0, 0, 4, 0, 0, 0, 1. Now here, again there is only need to get rid of this 4. So to get rid of this 4, I can add minus row 4 to row 2. So I will have here, I have 1, 0, 0, 0, 1 minus 1, 0, 0, and here I will have 0, 2, 0. I add minus row 4 to row 2, so this will cancel. So I will have 0, 0, and 0, 1, minus 1, 1 minus 1 minus 1, 0. Then I will have 0, 0, 3, 0, 0, 0, 1, minus 1, 0, 0, 0, 4, 0, 0, 0, 1. So I have this matrix, but since we should have the identity, there is 2 here, there is 3 here, and there is 4 here, right? But we need to have an identity matrix. So we should divide row 2 by 1 over 2, row 3 by 1 over 3, and row 4 by 1 over 4. Then I will get, I didn't change here, 1, 0, 0, 1 minus 1, 0, 0, I didn't change in the first row, so I will have, 2 over 2 is 1, 0, 1 over 2, minus 1 over 2, 0. Then I will have 0, 0, 1, 0, we divide row 3 by 3, and 0, 0, 1 over 3, minus 1 over 3, and I will have 0, 0, 0, 1, we divide row 4 by 4, I will have 1 over 4. So this is identity, 4 by 4 identity. So this one is the A inverse. So A inverse is equal to 1 minus 1, 0, 0, 0, 1 over 2 minus 1 over 2, 0, 0, 0, 1 over 3 minus 1 over 3, and 0, 0, 0, 1 over 4. This is the inverse. Second question is, find the inverse of the following matrix over the field F2 if it exists. So this is our matrix. And again we will do the Gauss-Jordan method, and we will get the inverse of this matrix. Let's say this is A, we will get the inverse A. Let's write it here. 1, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, 0, 1. It's like this is 5 by 5, right? So we need to write the E5, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 0, 1. This is the 5 by 5 identity. Now we need to find 5 by 5 identity this side. When we get 5 by 5 identity in this side, we will get the A inverse in this side. Right now, and this is A, and this is the 5 by 5 identity. Now, first let's look at this one. Now here we have 1 here, right? Below this one we should have zeros, right? This should be 0, this should be 0, and this should be 0. So we should add 1 to each row. Since we are F2, when we add 1 here, this becomes 0. When we add 1 here, this becomes 0, right? So we need to add row 1 from row 2, row 1 to row 3, row 1 to row 4, and row 1 to row 5. We should add row 1 to other columns. Then I will get here, let's look at, then I will get here 1 plus 1, sorry, this will be first row, will be the same, we didn't do anything to first row. Then I add 1 here, I get 0, there is nothing here, so I get 1, 1 plus 0 is 1, 1 plus 1 is 0, 1 plus 0 is 1, then 1 plus 0 is 1, 0 plus 1 is 1, and the other things are 0. Let's look at row 1 plus row 3. 1 plus 1, 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0. In the side we have 1, 0, 1, 0, 0. Let's look at row 4 plus row 1. 0, 0. 1 plus 1, 0. 1 plus 1, 0. 1. I have 0, 1, 0, 0, 1, 0. Let's get the row 5 plus row 1, 0, 1. 0, 1 plus 0 is 1, and 1 plus 1 is 0. Then I have 1, 0, 0, 0, 1. Okay. Now, column where this one belongs, all zeros other than this one. Now, we will look at this column. There is one here, right? So I want to make this one and this one 0. So I will add row 2 to row 3 and row 2 to row 5. So I will get rid of this one. There is 0 here and there is 0 here, so I don't have anything to cancel. Then I didn't do anything to row 1, so I will have 1, 0, 1, 1, 1, 1, 0, 0, 0, 0, and I didn't do anything to row 2, so I will write row 2 same, 0, 1, 1, 0, 1, 1, 1, 0, 0. Let's look at the row 3. We have 0 here. When I add 1 here, so I will have 1 plus 1, 0, 1 plus 1, 0, 0 plus 1 is 1, and 1 plus 0 is 1. Then I will have also here 1 plus 1 is 0, and 0 plus 1 is 1, 0 plus 1 is 1, 0, 0. And I didn't do anything to row 4, so I will write row 4 like the same. And I will have 1, 0, 0, 1, 0, and 0, 0, 1. 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 plus 0 is 1, and also I have 1 plus 1 is 0, 1 plus 0 is 0, 1, 0, 0, 1. So this is the middle one. Now, at row 5 there is 1 in the third column, right? At the third row there is 2 in the, there is 1 leading in the fourth column, and at row 5 leading 1 is in row 5, right? So we can switch this row between each other. So I can 2, row 5 and row 3. Then this will come to the here, and so this will come to the here. So I will get some matrix, then there is some thing, and then this row will be here, right? So I will change row 4 and row 5. Then I will have 1 0 1 1 1 1 0 0 0 0 1 1 0 1 1 1 0 0, and I have this one will be on the row 3, so 0 1 1 0 1 0 0 1, and then this row 3 will be in the row 4, so I will have 0 0 0 1 1 and 0 1 1 0 0. Then I will have this row in the row 5, 0 0 1 1 0 0 1 0. So I have this matrix, this augmented matrix. Now let's look at here. I have 1 here, right? But there is 1 and 1 here. So I should cancel this one. So I should add row 3 to row 1 and row 3 to row 2. Then I will have then I will have 1 0, like let's look at the row 3 plus row 1, 1 0 0, 1 plus 0 is 0, 0 0, and at the other side I have like 1 1 0 0 1. Let's look at the row 2 plus row 3. 0 1 0 1 0. This will become 0 1 0 0 0 1. I have this one, and I didn't change anything yet to row 4, row 3 and row 5. Now, this row, this column, okay, right? This column is okay. This column is okay. Let's look at here. This is the leading entry at row 4, right? It's the fourth column. But there is 1 and 1 here. So we need to get rid of this 1 and 1. So we should add row 4 to row 2 and row 3. Then I will get, I didn't do anything to row 1. There is nothing here. This will be the same. Then I will have 0 1, and I will have 1 1 1 0 1. And let's get this row 0 0 1 0 0 and 0 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, this will be the same. Okay, now this column also okay, but there's problem in the last column. One should be here, right? So other ones should be cancelled. So we need to add row 5 to row 2 and row 4. We need to add row 5, these two rows. Then I will have, again, we didn't change anything in the row 1. One, 0, 1, 0, 0, 0. This will become like this. Then I will have 1 plus 1, 0, 0 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1. Then I didn't change in row 3. I will write it's like the same. And let's get row 4, 0, 0, 0, 1, 0. This becomes 0, 0, 1, 0. Then I will have 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0. And I didn't do anything to row 5, so I will have this one. So augmented matrix become in this form. Now this one is the identity 5 by 5, right? After the Gauss order method we reduce to identity 5 by 5. Then this should be the I inverse. So A inverse is equal to 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0. So since I have a lot of computation, I can have mistakes. Please check that. Okay. Question 3 is prove that if A is n by m matrix and B is n by m matrix with n is less than m, then A times B is not invertible. Let's look at this one. Let us assume the contrary. Assume that A times B is invertible. And if you look at the system, let us look at the system Ax equal to 0. And this system, let's say this is the system star. Sorry, not Ax is equal to 0. A times B x equal to 0. Let us look at this system. Then the system, since A times B is invertible, well, the system A, B, x equal to 0 has only the trivial solution. Which is 0, 0, 0. 0, 0, 0, 0. Now, since this has only trivial solution, n is less than it has only trivial solution. Let's look at the b times x. Now, also we can also look at the the system bx is equal to 0. Now, b is n by m, right? And n is less than m. So we have an equation, we have m unknowns and n occursion. In this system, number of unknowns greater than number of equations, right? So b times x has a non-trivial solution. A non-trivial solution, say x prime. This is not equal to 0 vector. X prime is not equal to 0 vector. Now, let's look at the as a non-trivial solutions. Like, we are taking any of these solutions. And let's look at the and this is b times x prime is equal to 0. Let's look at a times b of x. And this is equal to a of b of x. And this is 0, so a times 0 is equal to 0. So, x prime is a solution for a times b. But in the beginning we said that if a times b is invertible, the system has only the trivial solution. But we find a non-trivial solution. So this is the contradiction. So a times b is not invertible. So this completes the question. Let A, B and A plus B invertible matrices show that A inverse, B inverse is invertible. Now, we know that A, B and are invertible, right? So this means that there exists A inverse, B inverse and A plus B inverse. And let's look at this one. A times A plus B inverse times B. So since A is invertible, A plus B inverse is invertible and B is invertible, right? This is the product of invertible matrices. So this is also invertible. Let's look at the inverse of this one. A times A plus B inverse, B inverse, inverse. Let's look at this inverse. So this is equal to B inverse times A plus B inverse times A inverse, right? I take this A inverse inside. Then I will have B inverse times inverse of inverse is itself. So we have A plus B. Then I will have A inverse. So this is equal to, when we take B inverse inside, I have B inverse of A plus B inverse of B times A inverse, right? Now, we know that B inverse of B is identical, right? So when I take this A inverse inside, I will have B inverse times A inverse plus B inverse, this is the identity times A. So A times A inverse is identity, so I have, this is A inverse, B inverse plus A inverse, and this is equal to A inverse plus B inverse. So inverse of this invertible matrix is A inverse, B inverse. So A inverse plus B inverse is invertible, and inverse is A times A plus B inverse times B. Question 5. Solve the following system of linear equation by using Cramer's rule, and the system is 2x minus y plus z is equal to 1, x plus 3y minus 2z equal to 0, and 4x minus 3y plus z is equal to 2. Now we need to use the Cramer's rule. Let's remind the Cramer's rule. And Cramer's rule says that if the system has a unique solution, this unique solution is x such that x size is equal to determinant of ai's over determinants a, and these ai's such that these ai's are the matrices obtained by A by replacing its ith column with the vector B. Like when we write matrix A here and B here, this is the vector B. For this system, this is the RB, this is the R vector B, and the coefficients of this system will be the matrix A. Let's write the augmented matrix first, and let's see what is RA and RB. Augmented matrix for this system will be 2 minus 1 1, and the other side we will have 1, and we have 1 3 minus 2 and 0 here, and we will have 4 minus 3 1, and here we have 2. So this is our augmented matrix, and this is our A, and this is our the vector B. Before trying to find AI's, let me first find the determinants of A, so we can guarantee that there is a solution, there is a unique solution or not. Since if the determinant is non-zero, then there is a unique solution. Let's find the determinant of A first. This will be 2 minus 1 1, 1 3 minus 2, 4 minus 3 1, and the determinant of this matrix is equal to, and let me look at, let's say change row 1 with row 2. Let's change row 1 with row 2, then we will have minus, right? If you change 2 rows, then the determinant has minus. So I will have 1 2 3 minus 2, and then I will have 2 minus 1 1, 4 minus 3 and 1. Then let's find the let's make this one and this one 0. So let's add minus 2 row 1 to row 2 and minus 4 row 1 to row 3. Then I will have 1 minus, there is minus here, 1 3 minus 2 and 0, minus 3, minus 2 times 3 is minus 6, so I have minus 7, minus 2 times minus 2 is 4, so I will have 5. And let's look at here, minus 4 plus 4 is 4, minus 12 plus 3 is minus 15, and minus 3, so minus 4 times minus 2 is 8, so I have 9 here. Then let's expand with column 1. I have only 1 here, so I will have minus 1 times 1 plus 1 is 1, 2, so minus 1 to 2 is 0, so 2, sorry, so I have nothing. Minus 7, 5, minus 15, 9, and this is equal to, and minus 7 times 9, minus plus 15 times 5, and this is equal to minus 63 plus 75. Then I have this one minus this one is equal to 12 minus 12. So determinant of A is equal to minus 12. Now, since we find the determinants, now we need to find the AI's and determine AI's. Let's first look at the determinants A1. So we will replace the first column by B, vector B. So I will have here 1, 0, 2 here. Instead of column 1, we will write this one. And then we will have minus 1, 3, minus 3, 1, minus 2, 1, right? So determinant of this one is equal to let's look at this one. So I can cancel this row, this one. I can cancel this one. I could add minus 2 row 1 to row 3. So then we will have 1 minus 1, 1, 0, 3, minus 2, 0, minus 1 times minus 2 is 2, minus 1, minus 2, minus 1. So now I can expand by column 1. Then I will have 1 times 3 minus 2 minus 1 minus 1, and this is equal to minus 3 plus 2 minus 2 minus 5. So x1 becomes determinant a1 over determinant of a, which is equal to minus 5 over minus 12, 5 over 12. Let's look at the determinants a2, and this is equal to, so column 1 will be the same. Now we change column 2 by b, so we will have 1, 0, 2, 1, minus 2, 1. So, okay, now we have this one. And this determinant is equal to 5. This is exercise for you. And determinant of A3. And A3 will be 2, 1, 4, minus 1, 3, minus 3. Column 1 and column 2 doesn't change, and we write 1, 0, 2 instead of B. And determinant of this one will be minus 1. This is exercise for you again. So x2 will be equal to 5 over minus 12 minus 5 over 12. And x3 will be minus 1 over minus 12 is equal to 1 over 12. So our vector will be our solution will be equal to the vector 5 over 12 minus 5 over 12 and 1 over 12. This is the solution of the system. And this was the end of the last problem solving session. See you in other courses. Bye.